Okay, this is a video about an experiment that I've been working on that will probably, have applicability for Final Fight as well as Samurai Showdown 2. So I kind of alluded to it before, the idea of, basically just using a pixel shader to set the palettes instead of, doing it with just multiple texture files. And so to do this, I put together a demo. So just to show you kind of like what's going on behind the scenes in the program. See right now, I have like this load Haggard textures function, and it basically says, okay, you know, for basically 11 different items, we're going to load up those 11 sets of textures, and for each one of them we'll store the textures in some slots so that we'll be able to grab it by that palette index. So essentially it's Hager's textures times 11. And like I said, there's pros and cons to that. It wastes a lot of memory, it slows down the boot up time, but it does give you the ability to basically make every color variation completely unique. Like you could just randomly add a tattoo or a mustache to one variation that isn't in the others, for example. But basically, after thinking about it, I'm pretty much reaching the conclusion that startup times, faster loading is probably worth the trade-off to make it a little bit more difficult to modify. Because I mean, honestly, like, who really gives a shit about modification? And also, just being so picky about every aspect of the game, I'm kind of more inclined to want to have control over each individual pixel, so I can do some special effects that I'll mention. So for this demo, for Guy, you can see here that I've basically made the Guy textures all load his orange texture, his orange default texture. So basically, I'm filling up all 11 of the slots with the same orange texture, but I'm testing to validate if my pixel shader is working to color those. So and then you can see the pixel shader here. Basically, I just have like a color map where I say, here are Guy's default colors, and then I can have an X number of color variations for each one. And so this is like a way more powerful way to control all these things, because you don't need X number of graphics anymore. You can just do it all programmatically in real time as you're running the game. And so just to show you, even though it's like it looks like Final Fight, right? Big deal. But I just want to illustrate though. So you'll notice like now that even when I have like a bunch of players come into the game, so even though I'm loading the orange texture, notice how they're all you got the different colors. And also notice how like on the portraits with their energy bars, they're all orange, because I haven't modified that function that loads in that renders their portraits to use the pixel shader. So I can verify that is when the pixel shader isn't being applied, and this is when it is being applied. So it pretty much works. And so and also if I load in more, see how like these ones that I haven't done yet, I haven't like plugged in the values. See how like they're messed up because the right values aren't plugged in, for those palettes. So those other guys aren't rendering correctly. And just as an example, so like starting with the fourth player, they're fucked. And so I can show you what he would actually look like. So basically, here are his colors, and then we have his default orange color, his green color, his blue color, and now here's the first one where you can see how they're just crap here. There's just like a solid blue for one, and then nothing's going on. So what I can do is I'll take his green color, which is the second one, and I'll just switch the green to red. Because basically it's just red, green, blue, and alpha, and so this would make it green. But all I have to do is to make this red, I can just get rid of these guys, and then I can just add in 0 for the blue. So recompile the shader, and then now when we join the game with a fourth player, the fourth player is going to be red. And then basically, so just some notes though. I mean, obviously there's different ways to do the pixel shader. Some more efficient than others. The way I have it right now is actually, very inefficient, GPU wise, because the pixel shader is based on conditions where you essentially have to like match the color and replace it with another one. But there are other strategies that you can use to make it faster. So now if I join the game with player 4, see how he's red. So see, it's like, I mean, so it's that easy now. It's like that easy to change the palette. It's like it's nothing, and that is genuine power, and that's pretty sexy. And the thing about it is, like I said, because this really gives you control over every pixel in the game. It gives you the ability to do a lot of really nice stuff that you couldn't do before. So like just as an example, so say you reserve a certain color for the shadows that are baked into the sprites. In the pixel shader, I can just say, I know that the character is, in the air, and I know that this color is a shadow color, so I can just not draw it now. So all of that is just like really awesome. It can basically give you flexibility to do that. Also, it can give me the flexibility, like I was mentioning before, to basically indicate whether a pixel is actually always full bright. So for example, if it's like the flame on the Molotov, even if you're in the basement stage and it's dark, you can say, no, this is a full bright pixel, so the flame will be at full brightness, whereas the bottle pixels are all colored by like the stage color. So there's all kinds of flexibility there. And this shit's gonna come in, like really handy when doing Samurai Showdown 2, because like the Neo Geo games, they molest palettes pretty heavily. Like they pretty heavily abuse palettes like everywhere. And so and because like one-on-one fighting games are just so simple, there's just nothing going on in them. You really can just kind of like throw all of your resources at just making everything as high quality as possible without really worrying about it. I mean, the other thing too you have to consider is, it's like, see the thing is, for simple games like this, for simple 2D arcade games, performance honestly doesn't matter. It really doesn't, because you got to figure 5 years from now, 10 years from now, people will be putting video cards in like groovy MAME setups that can molest this game at 8K resolution. Like it doesn't matter. It really doesn't. What's going to matter long term is how fast does the game boot up, and so this is going to significantly increase how fast the game starts, just because you're basically dividing all the textures you're loading by like 10, which is, I mean, that's pretty crazy. It's pretty big savings. So yeah, so you lose some flexibility in terms of actually making each color variation completely unique, but you gain a lot, from like all of the savings on memory there. And so you can see the pixel shader. Basically, what it's doing is, in my vertex shader, I basically send some properties as 4 floating point values. And those properties are basically, the first value is what is the object ID, and the second value is what is the palette ID, and the third value is the object airborne, and the fourth value is what is the current color of the stage. And then in the pixel shader, I passed in the output from the vertex shader, and so you get the color. This is like the actual color of the pixel before you do anything to it. And then I from the properties I get the object ID. So this for example 0 is guy, and in this case I'm just hard coding it just to look at guy. And so I say, okay, I know it's guy, and then I use that object ID to get guy's color mappings. And then, from the color mappings, based on the palette that I passed in, I get, the different mappings for a given palette. So if I pass in, 0, I'll get the orange palette, and if I pass in 1, I'll get the green palette, and so on. And then, so when you get those, colors, you basically then, loop through the different colors you get, and then you say, okay, does the current color match the color that I'm looking for to replace? And if it does, instead of taking the original color, I'll take the color in my color mapping, and return that. And so like I said, as you can see, this is a very inefficient shader because it has it branches in it. It has if conditions, and so what I can do is. Basically, let me see if I can find this. I don't know. Do I have anything here? Oh yeah, here we go. Yeah, this is what I wanted to show. So so what I can do is, if I redo all the graphics, if I regenerate all the graphics in the game and I make them all grayscale, what I can do is I can actually use those grayscale values as an index. To my color mapping. So for example, let's just say that I just say, all right, I'm going to potentially have up to 32 colors per sprite, which is double what the original Final Fight has. It's like generous. You really don't even need that many. And if I do that, I can basically have all these different, gray color values where RGB are all the same color. So 0, 0, 0 is the first one, and then 8, 8, 8 is the second, and so on. Okay, so basically what you do at that point is you just say, okay, so like let's just say that like the actual values in most of these 3D APIs are everything's floating point, and so to get the floating point value, these RGB values, you're essentially going to divide it by 255. So if I got a grayscale color that was 16. The floating point value, is really that. And so here's the cool things. This is like how this is nice. So this comes in as, the original value of the sprite. But then all you have to do is multiply that value by the number of palettes that you have. So if I have 32 in this case, I multiply it by 32. And then you can see that I end up, oops, didn't copy for some reason. Then you can see that I end up, if you round this, you basically end up with 2. And notice how in our palettes, 0, 1, 2. So it all lines up, and so 2 now becomes the index that you look up for the color mapping, and so that saves you from having to do any if conditions, because basically you can just process all the colors that are coming in. All of the sprites will be grayscale. They'll all be all these different colors, and then boom, there you go. And so the only problem with that though is, like I said, I have to go through and like regenerate the the graphics and make them all grayscale, and it also is again like one more level at which you're kind of making the assets impenetrable for just an ordinary user who like doesn't really know anything about computers. But it is a nice optimization. It's one of those things though where, I mean, honestly, even if you don't do this optimization, even if I left it as it is, it probably doesn't matter, because like I said, the game is so fucking simple that it probably doesn't matter. But if I wanted to get the performance, basically back to where it was, where it's like ludicrous, um, it would probably be worth doing this optimization. And I'll definitely do Samurai Shodown 2 this way. Because for Samurai Shodown 2, I'm starting from scratch, so there's no reason, not to do it this way from the beginning. Yeah, so Samurai Shodown 2's, graphics will all be grayscale. Um, but yeah, and I mean, and the thing is, I mean, you might, I mean, depending on how you do it, you still might need, like one branch in there for, handling whether you're going to zero out like the shadow pixels. I mean, it would probably be something like I said, you have to reserve some color for it. You have to reserve like some grayscale color, like maybe this, for example, 888, RGB, RGB, all the value 8. You might want to like reserve that for the shadow maybe. And if you do that, then you would say, oh, okay, it's like the magic, value or index. So if I also have the property that says that the character's in the air, I just won't draw the shadow pixels, for example. That's like one way you could do it. But in any case, yeah. So this is something that I'm kind of going back and forth on it. The game is pretty much done at this point. I pretty much have everything in there, and so now like that's why I've started fucking around with this. I really like having control control over every pixel though. It's really fucking nice. I mean the amount of textures you can get rid of is insane because I was saying that it's like what it is right now divided by 10, but it's really even better than that because it basically allows me to get rid of the textures that I had that were essentially just duplicates of other ones but had the shadows blinked out. So like yeah, so it is like the number of textures you can get rid of is actually pretty insane. Yeah, it's just that I'm kind of dreading, potential issues that I'll run into with, making all of the original graphics grayscale, because I'm just not sure if I'm gonna have to do some more work to make sure that there aren't collisions. At the very least, I'll have to go in and make sure that the shadows have, unique, colors. Because the shadows are they're not I can't make the shadows the same as other colors in the sprites, or otherwise it won't work because you'll be blanking out other pixels on the character, and also certain things in the game would actually have to be slightly redesigned because the current way like the current design is kind of it's kind of using the concept of like color variations for things that really aren't just like palette swaps. Like for example, like on the character select screen, on the character select screen, see how the the cursor for player 1 and player 2, it isn't just a palette swap because also the number of the player is baked into it. So for all these kind of like weird little corner cases, I'll have to kind of change the way the game works so that the cursor will then be a combination of text being synced up with the cursor, so I can draw the text numbers separately on top of where it is, but still use the pixel shader to actually color the red pointer versus the green pointer, etc. So there are certain things that I kind of leveraged the way it works currently, that won't apply anymore if I just universally use the pixel shader to set the palette everywhere. So or I could do kind of like a selective thing where I could only use the pixel shader for like certain objects. I mean I could do that too, but yeah, but the bottom line is a lot of design decisions I made though were because of the way it's currently structured. So if you go the other route where you just say screw it, pixel shader for all palette, for setting the palette everywhere, then that is a change. So yeah, I mean but what's really cool though is, I mean, this really does kind of put me there where like I really do have some really nice software that really can just do any type of 2D game. No, I mean, really, like any palette effect, any bullcrap, any scaling, any rotation. I mean, essentially, like, I mean, I can pretty much do any 16-bit arcade game. With what I have. Which is pretty nice. So in any case, that's just kind of like what I'm kicking around for doing the pixel shader. Yeah, it's something to think about.